A very good morning to all of you guys again. As you all know, my name is Chahel, and currently we are solving problems related to linked list on LeetCode. And today in this video, we are going to solve one more problem statement related to linked list. And if I'm being more specific, then today we are going to solve a LeetCode problem where we have to delete a middle of a given linked list. So firstly, we'll just go to the LeetCode problem set and we will look for the problem. Okay, so delete the middle node of a linked list. So as you can see that we are going to solve problem statement 2095, and you can see it's a medium level question. And firstly, in the description we are given head of a linked list. We have to just delete the middle node, then we have to return new head of a modified linked list. So as you all know that the middle node of linked list size n is n by 2th node starting from 0th base indexing, which we use in the array. And we have to, as you can see in example 1, total there are 7 nodes, and here you can see that 7 is the middlemost element. So what we will do is that in this the input is head equal to 1 3 4 7 1 to 6. So what we'll do is that firstly we'll calculate the middlemost node of the given linked list, and we will remove it. And what we'll do is that in the next of element before the node that is getting deleted, we will add the very next node of the element that is getting deleted. So after 4 here it will be 1, it will not be 7, and we will delete 7 in that way. So firstly, in worst case scenario, as you all know that if there is no head, or is no next of the head, then what we have to do is that we have to simply return null. Okay, so here we looked for the worst case scenario possible, and or else what we are going to do is that we are going to take a current node. So what a current node will do is that current node, it will keep track of the node before the middle of the linked list. So what we'll do is that in the current node that we will have before the middle of the linked list, the next of the current will be the next element after the linked list. And we are here going to use two pointer approach. As you all know that we have solved two pointer related questions one or two times in the previous video, and today we are going to same, and today we are going to do the same. And what we are going to do is that we are going to move these pointers unless and until the last of the linked list. And what we will do is that we will move the fast pointer 2 steps and we will move the slow pointer 1 step. So unless and until our list is about to end, we will have our slow pointer at the middle of the linked list. And what we will do is that we will just change the next of the element before the middle element, and we will return the new head of the linked list. So while fast is not equal to null, we are writing this because we have to traverse until the last element of the linked list, and while next of the fast is not equal to null. So we are writing this next of the fast is not equal to null is that this condition ensures that our fast pointer moves 2 steps easily. So firstly what we will do is that we will store value of slow pointer in current. So what it will do is that it will store the value of 4, and then we will move slow pointer as slow of the next, and we will move fast pointer as next of the next of the fast. So by the time our fast pointer is at 6, supposedly in this example our middle will be at 7. So what we'll do is that in current we are storing slow, so the slow will be 4 and next of the slow will be 7, and the next of the slow is the element that we are going to delete. So after doing this, what we are going to do is that here simply the next of the current is gonna be the next of the slow, as you can see here that the next of the current, it means the next of the current element 4 is gonna be the next of the slow. It means currently the slow is at 7, so next of 7 will be 1. And what here we will do is that we will simply return our new head. Okay, so we'll just try submitting this. Okay, so as you can see that all the three test cases of ours have been accepted, and we will just submit it and hope that we pass all the test cases. So here we are done. You can see the runtime is 3 ms, our beats, and we have passed all the 70 test cases. So here in this video guys, today we saw how to delete the middle of the linked list. Firstly, we will check if there is no head or there is only one element, then we will return null. And here what we will do is that we will use two pointer approach. The two pointer approach where the fast will move two steps and the slow one will move one step. By the time the slower one reaches the middle of the linked list, what we will do is that we will use another pointer named current. What current will do is that it will store the element before the middle node, and what it will do is that it will store the address of the next element after the middle node. So what will happen at the end is that our middle node will get deleted, and we will just return the new head, and we will set the next of the current as the next of the slow. So that was it for today's videos guys. I hope you liked the video, and thanks for watching.